Hello, everybody. My name is Eloi or Eloi. It depends if you want to pronounce that in a French way or English way. I'm working for Savoir-faire Linux, and I'm doing open source since a long time now, about 15 years. And I'm leading the TSC chair of SEAPATH, LF Energy SEAPATH. And today I will shortly explain you how we can elaborate kind of certification for SEAPATH, and specifically focusing on hardware manufacturers. Few words about Savoir-faire Linux. We are actually a Canadian and French company. We are doing business since 25 years in Canada and 10 years in France. We are not energy expert at all. We are working in many verticals. I personally was involved in train projects, avionics, multimedia projects. And actually that's also the value we are bringing to SEAPATH, for instance. It's our IT vision, I would say. We are a member of the LF Energy project, of course, and member of various projects like Yocto project, which is another Linux Foundation project. We actually start working on SEAPATH in 2019. Actually, I was the first guy working with them, and all the work we've done with RTE was actually become SEAPATH. That is now a major open source project of LF Energy. So I will try quickly, even that we have 10 minutes, to describe what is SEAPATH. So you have to see SEAPATH as the open source alternative to VMware for substation, to keep it short. The idea is to have an hypervisor to host virtual machines. And you may know that for TSO and DSO, the grid management is really critical, and the most critical part is what we call protection. So protection, the goal of protection is to make sure if a tree is falling down on the line, that you can cut the portion of the line that is involved, so that you don't have to shut down your country. And right now, you may know, and there is a demo that is just ending right now by our partner GE, doing virtual protection on top of SEAPATH, so that's why maybe you can have some people coming. You may know that it's very important, and it's a new way of managing the grid. It used to be in non-virtual environments before that. And RTE also is working on that, and many actors in the world. So what is important for open source hypervisors for the substations is to have a real-time environment. We need to be very deterministic. We speak about milliseconds to protect the line. So for instance, the demo of GE was about 7 milliseconds to detect a failure and to cut the line. So it's very short. And it needs to have a minimal jitter, right? And of course, we need to design that to operate on critical infrastructures. So if you come in infrastructure and you have access to the protections, you can have a shutdown in the whole country. So there is many requirements: deterministic, running the processing real time, the network latency, because we're actually receiving what we call sample values, IC61 sample values. It needs to be resilient. Again, it must work all the time, 24 hours. It needs to be cyber resilient. And the goal of SEAPATH that was initiated by RTE is also to be hardware agnostic. We don't want to have SEAPATH supported only for one typical hardware, and we need to go with the market. And of course, you're gonna run the software for probably 25 years, for instance, or even more. So you need to have somehow a long-term support. So why qualify hardware on SEAPATH? As I previously explained to you, the goal of SEAPATH is to deal with many hardware manufacturers. So it's true that right now, most of the POC developed on SEAPATH and on virtual platforms are done on Intel-based because they are on the market, but we can consider also other platforms like AMD, ARM, or whatever. You may know that on the Linux systems, for each hardware, you're going to have drivers running any specific component of the hardware. So you have a lot of different drivers that are going to be used, a lot of kernel subsystems that will be involved, and on top of that, you're going to design your applications that in this case will be virtualized. So what I want to explain to you here is that you're going to have many software configurations depending on your hardware. There is no one software that will run all the time. So this is quickly the stack of SEAPATH, which is against a Linux distributions doing hypervisors to host virtual machines. We are not reinventing the wheel. We are actually taking existing proven open source software. I will not describe everything. I will try to keep it short, but we have Linux kernel with PM30. We have KVM, QEMU, and libvirt to bring virtualization. That's what you've got when you are running traditional Linux distributions. You have Open vSwitch to manage virtual switching. And you have cluster capabilities to have SEAPATH running as a cluster to be resilient. So it's components developed by third parties like Red Hat, SUSE, named Pacemaker, Crossing, Stonish, and Ceph to do the data replication. And of course, we're using Ansible to use infrastructure as a code philosophy, meaning that we can deploy hypervisor very easily. We can manage that with the code and without human interaction. So this is interesting with the open source software. It's the way we are dealing with that. So I just took 3 examples. The first one is about the Linux kernel versions. It's on Wikipedia. You can see that between 2023 and now, you have about 10 releases of Linux kernel. And you can see also that the window of support is very short, except on some LTS versions. That is maybe about 4 or 5 years, and it's not frozen all the time. You also have the Civil Infrastructure Platform Initiative, CIP, that give you SLTS, but they are only supported certain versions. And of course, you need to be member of this Linux Foundation project because it needs to be funded. You need to pay some people to maintain that. And SEAPATH itself does not have a pure, everything supported with CIP. We will need to be member. Ceph, it's a Red Hat maintained software. You can see that it's the same issue. You have release all the time between 2013 and now it's very small releases. And SEAPATH itself, of course, we are pushing code every day because it's an ongoing project. There is many companies involved, RTE, Savoir-faire Linux, GE, and some others, Velotech, Schneider, whatever. They are like pushing code. And so we are reviewing, doing tests, but yeah, still it's moving, okay? So what I want to explain to you, it's almost impossible to consider you're gonna have one software, the same software running for 25 years, especially if you deal with cybersecurity, which is the main concern. If you want to fix cybersecurity issues, you need to update. And if you update, you're gonna need to check and to manage all the supply chain. So it's kind of crazy, but we have a concern that we want to have the confinement, the validation. We need to ensure long-term support and so on. We are dealing with fast evolution of open source. And what is the solution? It's always like this in every open source software. It's testing, testing, and testing. You need to test all the time, and you need to live with this supply chain that is moving very fast. So that's why in SEAPATH we have, since the beginning, we are running many tests, and we are running tests every night, every day. For each new contribution coming, we are doing regression tests, and we are updating different pieces of software very often. So now I will try to explain to you how we can qualify SEAPATH on real equipment, or we can qualify real equipment with SEAPATH, sorry. So it's something that we are talking with LF Energy staff. We are an open source project, so we want to have an open way to do that. So the idea, first of all, is of course to have an open process. All the CI that is already running is fully open source. You have access on that on the GitHub. We have already the ability to distribute that in different locations. So we have CI running at RTE offices near Lyon in Jonage and in our own offices in Reims. And you can definitely deploy in your CI everywhere. I know that some people are actually doing that. We also want to have open source tests. The idea is to share the test and to make sure that we can actually check that that's still true, and we can adapt that if needed. And of course, we are doing review and test of the test. And finally, we want to test what matters for substations: cybersecurity, real time, and we want to manage IC 61850, which is the data that is used by protections. So this is an example on the right. You can see the CI running. go on GitHub, SEAPATH GitHub page. You're going to see that it's running all the time. And I love to see red stuff like this. It means that we are doing something useful because we have some regulations sometimes, and we are fixing it. So basically, to keep it short, some details. Cybersecurity conformance, we are ensuring with ANSI offices that we are actually doing all the tests regarding Linux kernel. So that's an example on the right, where we're actually checking the Linux configuration. We are doing real-time testing with a well-known tool named Cyclic Test. We are running on real hardware, real-time test, and ensuring that it's matched what we want. And regarding IEC 61850, we're actually simulating sample value streams with pure software solutions for the moment. And we're going to have 8 streams sent, and we can measure the latency inside the virtual machines. So for people doing protections like GE, ABB, Schneider, that is a good way to ensure that the data they receive is received at a good time, and they can build the product on top of that. So what is next? We are actually speaking and elaborating that with LF Energy staff. Our goal is to check with hardware manufacturers and have kind of certifications on SEAPATH. So Savoir-faire Linux is a company, and it's also open to others. We want, as a company, to help hardware manufacturers to do this certification, to accelerate their adoption. We also want to do final testing. And we already are playing with real lab, with merging units, with Omicron. You can see the demo of G. Again, that was happening some minutes ago. And we want also to provide to utilities the ability to check that at the end the protection is running for a long time and that all the tests are okay. And this is, of course, something very open. You are hardware manufacturers, you are software providers, you are equipment provider, whatever. Please come to us. It's open. We can talk, and together we're gonna do something very awesome. Thank you.